All right. So the talk is titled "Get Productive with Scala Macros." Well, there's two of these screens. I don't know which one to look at. My name is, as I said, Pathikrit Bhowmick. I work in a hedge fund. I write Scala all the time. And this is my first big talk presenting to a big Scala group. And I decided to do live coding, which is a bad idea. I decided to do live coding with macros. So yeah, not that smart. All right. Let's see. OK, so just to set the expectations of this talk, this talk is not about Scala macro internals, like how the compiler works with it. It's not about compiler plugins either. All this kind of related. If you know macros, you probably know compiler plugins. It's not about Scala meta. That's the new stuff that's coming out. So this is literally about how to write your first first Scala macro project, how to get started with it. So I'll gloss over this part very quickly, like why macros are useful. Macros have understanding of more of the code that's surrounding it. So let's say you wanted to write a debug macro which prints out the variable names and the file name and the line number. You can do that. If you just do print line, it would just print out 23, hello, and 19 times 2. That's all it does. But with macros, you can do some powerful stuff. You can print out the variable names. That's a classic example of a debug macro. So what are macros? Without going too much into deep about it, the one-liner would be macros are code transformers. They happen during the compilation phase. They take code, abstract syntax tree, and produces some other abstract syntax tree, which is some other new code. So in Scala, when you write macros, it looks a lot like defs. It's just at least the def macros. So for example, like if we wanted to write this debug macro, it would look something like this. The signature would look exactly like a regular Scala def, which takes in any star args, returns a string. But instead of the body of the def, you use the keyword macro and say, hey, I'm going to implement it somewhere else in another special debug impl. OK, what does debug impl look like? It looks a lot like debug, except you have some other stuff. You have the context of the compilation, because when this thing is running, the debug impl, it runs during the compilation phase of your program. So you can know a lot about it. You can know the line numbers. You can do c dot enclosing position dot line. You know exactly what line it's working on. You can abort the compilation. So if there's something weird going on and you don't know what to do with the macro, you can call c.abort and with a nice message, and compilation would fail saying couldn't expand the macro. So OK, that's great. You have C. So where does it come from? It comes from this black box context. So without getting too much into the types of macros there's the big types are black box and white box macros. Black box basically means you guarantee that the code you produce would have that same signatures as expected by the compiler. So I'll get to that. And white box means you can generate pretty much any kind of code. So the black box macros are more well-known. I like them. They're kind of more strong assertions about them. So let's proceed. So in your debug impl, OK, great. You got the context. This part looks very similar to this part. So instead of any star, you get the syntax tree of the arguments. So instead of args, you get the syntax tree of the arguments. And it says that you're going to get an expression syntax tree of any star. And instead of returning a string, you'd return an expression tree of string. And we'll implement it in the live coding session. So macros are everywhere. You already use them a lot. These are some of my favorite libraries that use macros, and they're used everywhere, in play.json, in Slick. But most people shy away from actually using macros themselves. They would rather put it in SBT, import it, and go on. It's like someone else should write the macros, and let me do some coding, because that's just weird. But I'm here to argue that they're not scary anymore, at least. So before Kwazii Codes, macros were ugly. Because you as a programmer had to know a lot about the internal details of the Scala compiler, how the abstract syntax tree is structured. And if you're not a compiler writer, if you don't work in that level, you don't care, you don't know, you're not interested in that thing. So what I mean is, before Kwazii Codes, even if you wanted to do something simple as inject a list of 1, 2, and 3, this is what you had to do. And no wonder no one did anything with macros. You have to say that, OK, the 1 here is a constant. It's wrapped in a literal expression. Let's put all of them together in a list. They are all inside an apply, and all of this is an expression. With Kwazii Codes, just forget about all this. With Kwazii Codes is a very nice, you get this nice Q string interpolator. And it has 2 use cases. You can use it like this. So this literally means a fragment of code, a piece of syntax tree, abstract syntax tree, which evaluates to list 1, 2, 3. Great, that's it. This is equivalent now to what was pre-Kwazii Codes, what this was. But that's not the only thing. You can use Kwazii Codes in many powerful ways. Kwazii Codes are also extractors. So you can use them on the left-hand side. So given a function, given the abstract syntax tree of a function, you can do pattern matching. You can say, I know that a function has arguments and a body. Let me get them out. And you can get arguments and the body separately by using something like this. This is almost like regex extractors. You can say that, let me do my regex pattern on the left-hand side and the actual string regex on the right-hand side. And similarly, obviously, you can do this. You can also do the regular pattern matching. So you can say, given a tree, this is abstract syntax tree again, match. So what is this pattern? This pattern basically means it's an identity function. It takes some x, returns that x back. And it's, again, in the Q string interpolator. And you can do something with it. You can manipulate the tree, emit a new tree, throw some assertions, whatnot. And if it's not an identity function, you can take that context and abort the compilation and give a nice message, like, hey, I was expecting an identity function. But yeah, the point is, this is not scary. This is what we as software engineers normally are at the level of abstraction, at the level of code. We're not at the level of the compiler. And that's the main disconnect that I want to say, that it's not scary anymore. So, OK. So let's look at a real world problem. So if you're familiar with lenses, this would already look familiar to you. But let's take a real concrete example. Let's write a library that solves this problem. So let's assume that, let's say you have a garage. A garage has a car in it. A car has an engine in it. An engine has a version in it. So you see where this is going. And Scala, these are all nice case classes. They're immutable. When you want to update something, you get back a new copy of it. So let's say you had to write some code like this, which is upgrade the engine. And you're only given the garage. So what can you do? You can return a new garage back. And your code looks like this. You copy the garage. You copy the car inside the garage. You copy the engine inside the car, inside the garage. You add 1 to the version, and you return it. This code looks pretty, but you can smell it. Like this is a lot of code. Like all you want to do is this thing. So how can we can do better. We can do much, much, much better. So the first example, imagine you had something like this, an update function. So update function has 2 things, A and B, 2 types. It's a type parameter. So it takes in an original model. So in this case, your garage. It takes in a selector from A to B, so from garage to version. So selector basically says, given a garage, how do I get to the version of the engine of the car inside the garage? That's all it is. An updater says, OK, if you get the version, what do you want to do with it? I want to update it to some new version. And you want to get back a new A. So that's all this is, update. And this is how you'd use it. So you say update, you give your garage instance. And this is given a garage. This is a function which, given a garage, returns the version. And what do you want to do with the version? You want to add 1 to it. So how do you write this? Without macros, it's almost impossible to write this. I'd say it's impossible. You'd have to do very fancy type classing where you can say, like, this is copyable, this is updatable, and the internal you need to be familiar with. This is something that maybe Shapeless can do with some magic, but it's very, very hard, very hard. What I'm going to show you is literally going to be 7 or 8 lines of code. So how are we going to do this? We're going to use a very nice property of this update function. So what we'll say is, if you want to do this, and if this update is implemented correctly, it's equivalent of doing this, which is basically you copy the garage without macros, using the copy of the case class, and you update the car inside it. And instead of passing in the garage, you pass in this mygarage.car, and you give the path from car to the version, and you pass in the same function. So I hope it's clear to you that this will work. I mean, it compiles, so obviously it's correct. So, and okay, so what happens next? So if you see where I'm going, this is recursive. What's the base case of the recursion? The base case of the recursion is when you are updating the leaf node, which is the version, where x can be any x, in this case is version, and you don't have a path anymore. You have the identity function, because you're just updating the same thing. And you have the f. F is this whatever. You're adding 1 to it. So this is the base case, this f of x. So given this nice rule, this is called, if you're from category 3, this is telescoping of lenses. So this is a big lens. You compact it, it's like a telescope. Anyway, that doesn't matter, but this is a nice property we'll exploit. So with macros, what we'll try to do is, when we see a code like this, we will pattern match and see on this part, on this underscore.car.engine.version. If it is of length, or if it's not an identity function, we'll try to move the update inside. If it is an identity function, we'll just simply apply f of x. So I'm going to set up the mechanics. So the only thing we really need to do, like all this is easy. The only thing we really need to do is break this up. So we have this nice path of underscore.car.engine.version. We need to tokenize it. We need to pick out the car, so we can put it here, and remove it from this part so that we can write this part here. The rest is simple. And we need to put the car in here also, so update garage.car. And the rest is simple. This function remains the same. This is whatever you got. So let's see. So this is the fun part. OK. So this is a brand new SBT project. There's nothing funny going on. It has one dependency on Scala test and Scala reflect, nothing. I enabled language:experimental.macros. That's it. And the only thing I copy pasted was the test case. So this is, in the interest of time, I didn't want to write the test case out, but I copied from the slide. So you again have the garage, car, engine. You're upgrading the engine. This is a regular Scala def. And you create an instance of garage, G0. It's my garage. It has a BMW in it. It has an iDrive engine, and its version is 2014. And you have G1, which is using the regular non-macro version, this guy. This is the 4 or 5 lines of code. And hopefully you got back some different G1. But we're going to try to write the second version, G2, using our macro. This is, again, copied from the slide. And these are some assertions. That's all there is. This is the test case. OK, so let's write the update function. So this is I'm literally reiterating what's on the slide. So we want to update a model of type A. It has a selector function, which tells you how to go from A to B. It has an updater function, which tells you, given B, what new B you want to make. And it should return something of the original type A. OK, how do you implement it? Well, we're going to say it's a macro. So we're going to use the macro keyword and say it's implemented somewhere else. OK, how is it implemented somewhere else? So let's look at it. So we'll write update impl right next to it. It, again, takes in 2 type parameters, A and B. It's going to mirror very closely what update looks like. So the first thing it needs is the context. So it's not the string context. It doesn't suggest. It's the Scala.reflect, no, not remote, reflect dot, what is it? Macros dot black box dot context. This is the context I want. I'm going to write a black box macro. I mean, that's the macro we're all familiar with. I'm familiar with. So, and it takes in a model. And so instead of it being an A, it's the abstract syntax tree of A. So that's what it is. It's an expression of A, of type A. And it's an inner type of the context because this thing can change based on context. So, but you don't need to worry about that. So a selector is, again, instead of being a function from A to B, it's the extract syntax tree of the function whose type is of A to B. An updater, is the same. You guess where it's going. It's the same deal. It's instead of being a function from B to B, it's the. I think I'm going out of the screen, so I'll put it in the next line. So it's the syntax tree of the function from B to B. And what do you want to return? You want to return, instead of A, you want to return the abstract syntax tree of something that of type A. OK, let's do this. What's the simplest thing I can do? I can do nothing. I can return the original model back. This compiles. And let's see if it works. It won't. So I hope it doesn't download jars. OK. It's too big font. Yeah, it didn't work because what I did was I just returned the original model back. It says 2014 did not because I didn't do anything with it. OK. Let's try to do something interesting with it. As I said, what we want to do is break the selector apart. Like everything else remains the same. The updater for sure remains the same. The selector, we need to tokenize it. So we want to break this underscore dot x dot y dot z into x comma y dot z. So OK, let's look at what the selector looks like. So this is the selector. So mind you, at this point, this is not the argument. This is, again, everything at this point you have is not the values. This is the abstract syntax tree of this argument. OK, so let's see. So selector.tree, what is it? We know it's a function. So let's pattern match. So what's the pattern matching for a function? It's something like that. It has an argument and it has a body. And you put it in this queue, magic interpolator. So yeah, let's see if that works. And it's complaining that it doesn't know what the interpolator is. So you need to import all that using. You need to import every mechanism from this universe of this context. So you need this thing up here. So now it knows what Q is. So I don't know what the body looks like. Do you know? I don't know. Like I have a guess. It looks like underscore dot car dot engine dot version whatever. So what I can do is print line, my good old debugger. So there's this nice little util that Scala macro paradise provides called show code. And you can pass in the body, and let's see. And I mean, I can't put a breakpoint here because this is code that's executed during compilation. So, OK. So, let's see. There you go. It printed the body out. Cool. This is exactly what I expected it to be. This is what underscore dot car dot engine dot version looks like to the compiler. Awesome. So I need to disassemble the body. So what I want to do is, given some code that looks like underscore dot car dot engine dot version, I want to return list CEV. I want to tokenize it because I need to take that car portion out and move it in the front. So what do I pass in? Well, I pass in whatever body is. So body is let's see, it's just an expression at this point because body, which is of type C dot expression, or sorry, it's a syntax tree. So it's a C dot tree. That's the most generic thing I can talk about it. Because if I use expression, I have to give it a type. At this point, the type is hard because I'm going to use it recursively. So given C.tree, I want to return a list of terms, which are these things. So some of you might be asking, how did I know it was a tree? How did I know that it's going to C dot term name? There is a nice Scala doc page which lists all the things possible. You can also do, instead of show card, you can do show raw. And this would print out what it was. So show raw would say that it's select, 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 term, 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 term. So yeah, I want a term. If you still can't figure it out, ask on Stack Overflow. It will get answered in like 1 minute by someone from this conference. So yeah, there are many ways. So that was one of the hurdles. Like, you don't know what body is. What is the pattern matcher? What's the correct pattern matcher to use? You can either use show code or show raw, or just ask. Anyway, that part is actually very easy. So what I want to do is, what does body look at this point? Good old print line. Well, I know what body looks like. It looks like somewhere back up here. It was list of something dot, something dot, something dot. OK. Well, let's pattern match, our favorite tool. So it has a parent and a child. So in this case, oops, it's not Ruby or anything. So parent at this point would be, if you're given _.c.e.v as body, the parent would be till this point in time, or till the it's basically the head or the init of the body, and v is the last thing. How do I know that? Well, again, print line, show code, parent and child. OK. So we're going to recursively disassemble the parent and append the child to it. So this is nothing fancy I'm doing. All I'm saying is recursively, I know how to disassemble CEV. How do I do that? Disassemble CE and append V to it. And what's the base case? Well, the base case is, this is not the actual base case, but I'll go with it. So base case is you got back the identity, which doesn't have a parent and child. But at this point, if you're a real library writer, you would do some more assertions. You want to make sure that this is the identity function. And if it's anything else, you want to abort the compilation and say where it failed in the enclosing position. And you want to give it a nice error message saying expected something like _.x.y.z, else this macro doesn't work. It only works for case classes with nice nice functions which has like foo.bar.z. So, but that's fine. We're not writing library. We're live coding during a conference, so we can say that this is what it is. I mean, worst case, it would happen. The pattern matching would fail, and you'd get a match error, which is fine too. So back to this trick I'm going to use. I'm going to move the update one level down and pick the car up, put it here, pick the car up, put it here, change the selector function. All right, let's do that. That should be easy. So again, I'm going to use Q, but on the right-hand side now. On the right-hand side, I'm going to use it as to create a new syntax tree. So what I'm going to do is do $model. So this is the outer model. .copy. Well, let's disassemble the body first. So disassemble the body. And let's do pattern match on tokens. So this is the first token, rest of the tokens. So T1 is the car, model is the garage. So I want to do T1 equal to, I'm moving the update down. I had to use $T1, so I don't use the string T1. So I want to update dollar model dot dollar $t1. This is not something magic I'm writing. I'm literally writing this code, this thing. And I'm calling model is my garage, T1 is car. That's all I'm doing. So and we need to pass a new function to new selector function, but the updater function remains the same. So the updater passed down the updater. And the base case of the recursion is when you don't have any tokens. So the base case of the recursion, this one, and you don't have any more tokens, you just apply f to x. So you just say dollar updater on dollar model. That's all I did. OK. So now the one missing part is the selector function. So what the selector does is takes this car engine version, takes the car out. So we need to so we already have list CEV. We need to reassemble it. So reassemble the body back. So now we have this is exactly the opposite of disassemble. So now I have a list of terms, list of c dot term name, and I want to return a c dot tree. And this is actually, so what I'm doing is list of CEV. I want to return a tree which looks like underscore dot c dot e dot b, because I'm putting the selector back again. So, huh?
The list shouldn't be named C. You're already C.
Tokens. Good point. And now it should be fine. Yeah. Thank you. So how do we do this? Well, this is actually easy. We just fold it. So fold left. We start with what do we fold left with? Well, what's on the left-hand side? This guy. What is this? This is the identity function. How do you write an identity function? So boom, that's an identity function. And what's the function? What's the folder? So this is the function, and you have t. You need to now just append the t, these terms at the body of the function. So function, again, we're going to pattern match. It's exactly this thing, because that's what functions look like as far as quasiquotes Scala compiler is concerned. And we want to return, instead of dollar body, we're going to return dollar $t, where if you see that I'm just reassembling, I'm appending, starting with the underscore, the identity function, I'm putting the C in the end, then putting E in the end, putting V in the end. That's a simple fold operation. So so here, what I want to do is reassemble the tail. OK, did I misspell reassemble? Let's see. I'm missing a bracket. Sorry, it's kind of hard to see. Yeah, it's missing a paren inside a Kwazii code somewhere. Fold left. Oh. Oh, I see. Which one?
In your Kwazii quote, you have reassemble. It's treating that as like a single term in the quote. But if you wanted to take arguments, you have to put curly braces around it. Yeah. So put the starting curly brace.
This thing. Yeah, you're right. And I don't need the dollar anymore because it's a send a curly. And the updater is fine because it's a single. Yeah, the rest of them are fine. Yeah, let's see. And now instead of passing in, well, let's print out what this new code looks like. So good old print line. And instead of returning back the original model, we'll return code dot the code. Right. I'll just print out the code. So now I hit an interesting thing. It's complaining that, hey, I'm not returning c.expression anymore, because at this point, the type checker gave up and said, like, I don't know, this is of C of expression A. So I will say, like, even if it's a black box macros, let me relax a bit. It's going to be c.tree. I'm returning an abstract syntax tree instead. That's fine. If you can hit Alt-Enter, IntelliJ will do that for you, which is fine. So let's see. Oh, I need to actually return the tree. So,
You have a string S string interpolator and the
yeah.
underscore.
Thanks having a debugger around. Okay, cancel. Oops. Okay, let's complaining about disassemble somehow. So let's look at disassemble.
It's not pattern matching.
Yeah, right. So what I want to do is this. Yep, that worked. My test pass. And you can see it's recursively resolving the update. It's doing the first time, it's moving the update out from the top level, saying, let's update the car. When it sees that, it moves the update inside the engine. And when it sees that, it moves the update inside the version. And this is the base case. It just says, like, hey, I'm going to update this anonymous function, which is add1, to the version. And voila, it works. And thank you. And this is not hard code. Like, I was super nervous live coding and somehow managed with the debugger from there. But anyway, back to if we have time. Yeah, cool. We don't have time for problem 2, but this is another real life problem where you have a business model and you want to write a strongly typed REST API. So let's say when you are posting a user, you don't have his ID. It's created by the database. When you get a user, you don't want to pass the registration time along. And when you patch a user, you can only patch the name. OK, fine. You wrote 4 classes, great. But now you have to add phone number. Now you have to go put it in all of these classes, figure out how they map to the database, figure out how they map to the original business layer. And these are your presentation layer models. So it can be solved with macros. It's about 30 lines of code. You can use, instead of def macros, annotation macros, you can say, this ID is only in the get model. Name is in the get post batch, email, and registered on is never exposed to front-end APIs. That's possible. So there's more to macros, like all these things, implicit macros, fundamental, and they all sound complicated. No one wants to get into it, or the people who wants to get into it are like the few people in this conference. But if someone shows you how to get started, it's not scary. It's actually very easy. It's something worth doing a Scala workshop on, like going through all this live coding. And one day, everyone would be an expert, and it would be awesome to use it in your own libraries. Yeah, that's my talk. These are the actual solutions to problem 1 and 2. These are real-life libraries. They're available on Bintray. I use them in my projects every day. Some other people also use it. So thanks. Any questions? Yeah.
Using the Kwazii Codes, isn't this like kind of fragile? Because if you pass in the function, let's say instead of using the arrow notation or underscore, you define a div somewhere and just give the name of the
Yeah, it's as long it's sorry. Since you did something bad, it will not compile. So that in my definition is good. The code?
Yeah, the update example.
Yeah.
Where in the macro generate version there, we have actually one thing which is less efficient than the handwritten version, right? You don't inline the function, the updated function in the end. You're actually creating a function over there, whereas in the handwritten version, you probably will not do that.
Right. You can make actually in the link I posted. This is actually is evaluated. It's evaluated as a block which applies the function. That's a small change you can do, but yeah, I agree. But the generated code looks very similar to this, and you can do a lot of powerful things, like you can create a lens operator which just has this two, and the third one is anonymized, and you can reuse that lenses to apply on the same object. Yeah.
So how forgiving is the quasi-quote when it comes to like things like in your pattern match down below you have parentheses around arguments, but if it takes a single argument you can leave the parentheses.
Yeah, it's very forgiving. You can put this thing in, wherever I use the identity somewhere. I think in my fold, you can put arguments around it. It's fine.
Okay, so
Yeah.
it tries to interpret
Yeah.
what it would.
Yeah, it actually uses like the Scala AST transformer to actually parse the quasi-code out into the pre-quasi-code Scala AST. So if that works, it will probably work. So it's not out. It's like I'm not the macro internal expert, but it works. It's very forgiving. All right.